This is review exercise of C4 paper, and these sums deal with parametric equations. In the first question it says the curve C is described by the parametric equations x equals to 3 cos t, y equals to cos 2t, and we have to convert this into Cartesian equation. Whenever you have to convert a parametric equation into a Cartesian equation, it is always important to have some sort of a connection between the two. One way of doing that connection is using a trigonometric identity. Now first let me write this out. X equals to 3 cos t. That means instead of cos t, I can send the 3 to the other side. I can write cos t equals to x by 3. And the next one is y equals to cos 2t. Cos 2t can be broken down as the double angle half angle formula. It can be written 1 minus 2 sine squared t. So 2 sine squared t equals to 1 minus y. Therefore sine squared t equals to 1 minus y by 2. We have found two values. One is cos t is x by 3, the other one is sine squared t is 1 minus y by 2. The identity that can be used is this one. Sine squared theta plus cos squared theta is identical to 1. This is an identity that first comes in C2. So what we can do here is we can write hence sine squared t plus cos squared t is identical to 1. Instead of sine squared t, I can plug in 1 minus y divided by 2 plus cos t is x by 3, so cos squared t is going to be x by 3 whole squared equals to 1. This is the Cartesian equation. This can be further simplified and we can have an expression of y in terms of x. So 1 minus y by 2 equals to x squared plus x squared by 9 equals to 1. So we can write 1 minus y by 2 equals to 1 minus x squared by 9. If we multiply by 2 to the other side, it would be 1 minus y 2 into 1 minus x squared by 9. So 1 minus y equals to 2 minus 2 by 9 x squared. So it would be y equals to 1 minus 2 plus 2 by 9 x squared. So 1 minus 2 is minus 1, so this would be 2 by 9 x squared minus 1. So this is actually a quadratic equation. The point P has coordinates x coordinate a and y coordinate 4. This is a Cartesian coordinate. Whenever we are talking about a point, it has to be a Cartesian coordinate with x coordinate and y coordinate. It lies on a curve. This capital letter C denotes the name of a curve, and the curve has parametric equations. X equals to 3t sine t and y equals to 2 sec t. So that's what it says. Now we have to find the exact value of a. So what we can do is we can first put the value of y. So at P, y equals to 4. So we can plug it here. So 2 sec t equals to 4. So we can write 2 by cos t equals to 4. If we do cross multiply, it would be 2 by 4 means half equals to cos t. So cos t equals to half. Therefore t equals to cos inverse of half. Cos inverse of half is going to be, if you think about this, think about this C2 rule. When we have a triangle like this, this is 1, this is root 3, and this is 2, and this angle is 60 degree and this angle is 30 degree. So if you think about cos 60 degree, so cos 60 degree is going to be adjacent by hypotenuse, which is half. So if you want to know cos something equals to half, that means 60 degree, and 60 degree means, remember, pi by 3, because pi refers to 180 degree, so pi by 3 means 180 by 3, that is 60 degrees. So this answer is going to be pi by 3. So once we know the value of t, it's pi by 3, now we can find the value of a. So we can say, when, let's move to here, when x equals to a, let's put it here. So at x we're putting a, so a equals to 3 and t equals to pi by 3. So 3 pi by 3 sine pi by 3. So this 3 and this 3 cancel, so this is pi. Now sine pi by 3, so if you look at 60 degree denotes pi by 3, so sine pi by 3 is going to be sine 60 degree, it's going to be opposite by hypotenuse, square root 3 divided by 2. So we can write square root 3 by 2. So a equals to pi square root 3 by 2. So this particular sum, we have the curve with parametric equations, x equals to 2 cot t and y equals to 2 sine squared t. So the first thing that we have to do is find an expression for dy by dx in terms of t. Now you remember that dy by dx for parametric equation is dy by dt divided by dx by dt. So that by chain rule becomes dy by dt multiplied by dt by dx. So this dt cancels and we get dy by dx. So that's how we get the derivative of a parametric equation. So the first thing that we have to do is we have to find dy by dt. So if we differentiate y, so y equals to 2 sine squared t. So therefore, so the derivative of y in terms of t is dy by dt. Remember, we are not differentiating in terms of x, we are differentiating in terms of t. So here we have a power. So the rule for derivative of power is this one. So remember, d by dx of ax plus b to the power n is going to be n, then ax plus b to the power n minus 1 into the chain rule d by dx of ax plus b. So that's what we have to do here. So in this particular case, we have this 2 as the power, this 2 as the constant, and this 2 as the power. So the power comes first, so this 2 would come first, and then we write the same thing with the power decreased by 1. So if the power is 2 here, if it becomes decreased by 1, it would become only sine t, and then d by dx of the algebra, whatever is inside the power. So inside the power we have sine t, so we have d by dt of sine t. So that's what we have to do here. So now if we simplify, 2 to the 4, sine t would be sine t, and d by dt of sine t is going to be cos t. So dy by dt is 4 sine t cos t. Next we have x equals to 2 cot t. So therefore we have to do the derivative. So d by dt of x is dx by dt equals to now the derivative of cos. Now if you remember from C3, d by dx of cot ax is minus cosec square ax into d by dx of the chain rule, the angle. So remember, the derivative of cot is minus cosec squared theta, whatever the theta would be here. So by that formula, the 2 would be 2 and this would be minus cosec squared theta. The angle is t here, and d by dx of the chain rule t is going to be 1. So this would be minus 2 cosec squared t. Now since we have found both dy by dt and dx by dt, so we have to find the derivative now. So therefore dy by dx is going to be dy by dt divided by dx by dt. So this is going to be dy by dt is 4 sine t cos t, and dx by dt is minus 2 cosec squared t. So this 2 and this 4 cancels, 2 to the 4, so we have minus 2. So we have sine t, we have cos t, and this one cos squared downstairs. If you remember the identity, again the C3 identity, the identity says that 1 by sine theta is identical to cosec theta. So cosec theta is the reciprocal of sine theta. That means sine theta is also the reciprocal of cosec theta. They cross multiply. By that rule, we can easily say that the cosec squared theta downstairs, meaning 1 by cosec squared theta, if you bring it upstairs, it would become sine squared theta. That means minus 2 sine into sine squared theta is sine cubed theta. I'm referring to theta as the angle here. That angle is t, and cos t. So the derivative of the gradient of this is minus 2 sine cubed t cos t. Now we have to find the equation of the tangent to the curve at the point t equals to pi by 4. Whenever we have to find the equation, we have to remember the rule for C1. So the C1 rule says, let me scroll down here. So by the C1 rule, we remember equation of a line is, if you have this and x1 y1 and this is the gradient, so the equation of the line is y minus y1 equals to m x minus x1, and the gradient rule for a tangent is that gradient of tangent equals to the gradient of the curve at a particular point. So this is the gradient rule, meaning this is how we calculate the gradient m, and when the point is given, we can easily find the equation of that line using this formula y minus y1 equals to mx minus x1. So here the question is, find the gradient, find the equation of the tangent. So for the equation we need two things. We need the point through which the line passes, and we also need the gradient of that particular line. So at the point t equals to pi by 4, so for question number B, we can write at t equals to pi by 4, dy by dx equals to minus 2 sine, here we put pi by 4 whole cubed. Sine cubed means sine theta whole cubed, and cos pi by 4. So minus 2. Again, from a triangle we can easily see, from this triangle, this is a C2 rule, if this is 1 and this is 1 and the Pythagorean theorem says this is square root of 2, this angle is 45 degree. So by sine 45 degree means pi by 4 is opposite by hypotenuse 1 by square root 2, and cos 45 degree is adjacent by hypotenuse 1 by square root of 2. Pi by 4 means 45 degree, 180 by 4 means 45 degree. You have to memorize this. This is a rule from C2. So what happens here is that sine pi by 4 is 1 by square root of 2, so 1 by square root of 2 whole cubed, and cos pi by 4 is 1 by square root of 2. One thing is important, the third rule, 1 by square root of 2, 1 by square root of 2, if you multiply upstairs and downstairs with square root of 2, it becomes square root of 2 into 1 square root of 2, and square root of 2 into square root of 2 is 2. So 1 by square root of 2 and square root of 2 by 2 is the same thing, just different ways of writing it down. By simplifying this, we get minus 2 1 by square root of 2 to the power 4. That means minus 2 1 by square root of 2 whole square into 1 by square root of 2 whole square. That means minus 2 1 by square root of 2 whole square means 1 by 2, and 1 by square root of 2 whole square means 1 by 2. This 2 and this 2 cancel, so we get minus half. So if the gradient of the curve at the point t equals to pi by 4, remember this is the parametric format of a point. A point in Cartesian has an x coordinate and the y coordinate. So if the curve has gradient minus half, so the gradient of the tangent, would be the same, because the gradient rules say that the gradient of the curve at a particular point is the same as the gradient of the tangent at that particular point. So now we have the gradient, we need the point. So at, again, t equals to pi by 4, we need the value of x. Now x equals to 2 cot t. So 2 cot t. So we know the identity cot t is cos t divided by sin t. Again we have this identity, cot theta is identical to cos theta divided by sin theta. Tan theta is identical to sin theta by cos theta, and the relationship between tan theta and cot theta is that the reciprocal of tan theta is cot theta. So these are the identities that we need to do. So here, when t equals to pi by 4, you can plug it in here. X equals to 2 cos pi by 4 divided by sin pi by 4. So we know from previously cos pi by 4 is 1 by square root of 2, and sin pi by 4 is also 1 by square root of 2. So we can cancel this, and the x coordinate is 2. Now we need to find the y coordinate. So y equals to two sine squared t. So 2 sine squared t means sine pi by 4 whole square. So this would be 2 1 by square root of 2 whole square. This would be 2 1 by 2. This 2 and this 2 cancels, and this is 1. So the point that we are looking for here, where the parametric value is pi by 4, the point is x coordinate 2 and y coordinate 1. Now we can find the equation of the tangent. So equation of the tangent is y minus y1, which is 1, equals to m, the gradient was minus half, into x minus x1, which is 2. So we can now simplify, multiply by 2, it would be 2y minus 2 equals to, we have minus 1 left, minus 1 into x is minus x, minus 1 into minus 2 is plus 2. So we can further simplify this and write 2y equals to minus x plus 4, or we can write 2y plus x equals to 4. Remember, if they do not mention any format of the equation of the line, you just keep the line as you want it. The final question is, find a Cartesian equation of the curve in the form of y equals to fx. That's the final question. So x equals to 2 cot t, y equals to 2 sine squared t. Let me scroll down here, move here. X equals to 2 cot t, y equals to sine squared t. Let me double check. 2 cot t, 2 sine squared t. This is 2 sine squared t. Okay, so from here we get x by 2 equals to cot t. We get an expression for cot t, and from here we get y by 2 equals to sine squared t. So we have an expression for cot t and an expression for sine squared t. So let's write down the identities that we have. Remember, whenever we have to convert the parametric equation to Cartesian, we need some sort of an identity to connect the two. Now the identity with cot theta is cot squared theta plus 1 equals to cosec squared theta, and sine square, we also know that identity, that cosec squared is 1 by sine squared theta because they're identical. So we can easily use this identity to put these two and have the Cartesian equation. So cot squared t plus 1 equals to cosec squared t. So at cot squared we can just plug in x by 2, so x by 2 whole squared plus 1 equals to, at cosec squared we can write cosec means 1 by sine squared t. That means x squared by 4 plus 1 equals to 1 by sine squared, we can put y by 2. So that means x squared by 4 plus 1 equals to 2 by y. Now we have to express the answer in the format of y equals to fx. So now what we have to do, first of all we can multiply both sides with 4 to get rid of this 4. So we can write x squared plus 4 equals to 8 by y. So 4 into this, 4 cancels, we have x squared, 4 into 1 is 4, 4 into 2 is 8, so 8 by y. So we can cross multiply, send the y upstairs and this expression downstairs. So we can write x squared plus 4. So this is the expression we have been looking for. So y equals to 8 divided by x squared plus 4. This is the Cartesian equation. There's one more question here. It's about the domain of this function. Domain is something that makes something possible. So restriction is there. So when you have a domain, the question is for what values of x we have a value of fx, an output of fx. So if you have no output, that means that domain for that function is not possible. For this particular domain, if you put the value of t here, t equal to 0 here, so let me put it here. Of course we can also find the domain from this Cartesian format, but it's easier to use that domain. So we have the values of t, so x equals to 2 cot t. So 2 cot t means 2 cos t by sine t. So if you put the value of t equal to 0, x becomes 2 cos 0 divided by sine 0. So cos 0 is 1, sine 0 is 0, so it is 0. Actually this particular value, nothing can be divided by 0. This is undefined or cannot be determined. So this is one value. If you put t equals to pi by 2, x equals to 2 cos pi by 2 divided by sine pi by 2, so this is going to be 2 cos 90 degrees 0, sine 90 degrees 1. So 0 divided by 1 is 0. That means we can have a range of value of x which is greater than or equal to 0. Of course it's not very obvious what it is going to be. It's more helpful if you have an idea of the sketch of cot theta, but it's a quick way of finding the domain here. Question number 70, we have parametric equations given and we have to find the equation for we have to find the expression for the gradient. So first we know dy by dx is equals to dy by dt divided by dx by dt. So from that we can write, if we differentiate y in terms of t, dy by dt would be 7. The derivative of sine t is cos t. The angle is t, so the chain rule would be 1, so I'm not writing it, minus sine 70. So the derivative of sine theta, if I consider 70 to be theta, sine theta would be cos theta, meaning cos 70, into derivative of 70 is 7, the chain rule. So I can write 7 cos t minus 7 cos 70. Now let's move on to the derivative of x. So this should be t. So dx by dt would be equals to 7 is the number. Derivative of cos t is minus sine t, minus the derivative of cos theta is minus sine theta, so minus sine 7t into d by dt of the angle 70 is 7. So what we have here is minus 7 sine t plus 7 sine 7t. So therefore dy by dx is dy by dt divided by dx by dt. So dy by dt is 7 cos t minus 7 cos 7t divided by we have dx by dt, which is minus 7 sine t plus 7 sine 7t. So this is the derivative that we have here. Let's move on to question number B. Let me do it here. Question number B is we have to find the equation of the normal to the curve at the point t equals to pi by 6. First of all, let's find the gradient. So at t equals to pi by 6, we have dy by dx equals to 7 cos pi by 6 minus 7 cos 7 pi by 6 divided by minus 7 sine pi by 6 plus 7 sine 7 pi by 6. Okay, now we know from that C2 triangle that if you have this is square root of 3, this is 1, and this is 2, this is 60 degree, and this is 30 degree. 30 degree means pi by 6. So cos 30 degree or cos pi by 6 is adjacent by hypotenuse, which means square root 3 by 2. Sine pi by 6 or sine 30 degree is opposite by hypotenuse, which means 1 by 2. So if we plug in the values, this would be 7 square root of 3 by 2 minus 7. Now this one 7 pi by 6, so what the value can be? So it means actually pi by 6 7 times. So it's a good idea to use the calculator for this particular value. So let's bring out the calculator. So this is the calculator, so we can use 7 pi by 6. Instead of converting this into the radian mode, we can do this in our head. So pi by 6 means 30 degree, 7 pi by 6 means 7 into 30 degree, that means 210 degrees. So cos pi by 6 means 7 pi by 6 means cos 210 degree. That means minus 0.866. 0.866 is just a decimal format of square root 3 by 2. So minus 0.866 means minus square root 3 by 2 divided by minus 7 sine pi by 6 means sine 30 degree, which is half. This calculation is a bit lengthy, plus 7. Now sine 7 pi by 6 meaning sine 210 degree, so that means sine 210 degree is going to be minus 0.5, meaning minus half. So let's calculate this. This is 7 root 3 by 2 plus 7 root 3 by 2, and this is minus 7 by 2 minus 7 by 2. So this is going to be 7 plus 7 14 root 3 by 2, and this is minus 7 by 2 minus 7 by 2 is going to be minus 7. Now if we cancel this off, this is going to be 7 2s are 14, so we can write minus 2 square root of 3 by 2. So this 2 and this 2 cancels and we get minus square root of 3. So that's the gradient of the curve at the parameter t equals to pi by 6, which means a Cartesian point. So we know the gradient. So the gradient of the normal would be gradient of normal. Remember, the gradient of the normal is a negative reciprocal, so minus 1 by minus root 3, so it would be 1 by square root of 3. Now we need to find the point. So at t equals to pi by 6. So first we have to find the x coordinate. So x coordinate would be 7 cos t minus cos 7t. So cos t minus cos 7t. So cos pi by 6 means cos 30 degree is square root of 3 by 2 minus cos 7 pi by 6, which is calculated, it is minus root 3 by 2. So that means 7 root 3 by 2 plus root 3 by 2. If you add, it is 8 root 3 by 2. So this 2 and 8 cancels with 4. So 4 square root of 3. And we have to find the value of y. So y equals to 7 sine t minus sine 7t. So 7 sine t minus sine 7t. So this would be 7 sine pi by 6 is half minus sine 7 pi by 6 is minus half. So this would be 7 by 2 plus half. So this would be 4. 7 by 2 is 3.5. 3.5 plus 0.5 is 4. So we have the point x coordinate 4 square root of 3 and y coordinate 4. Now the equation. So equation is y minus y1, which is 4. M is 1 by square root of 3. X minus x1 is 4 square root of 3. We can leave the sum in this way, or we can simplify. So if we simplify, square root of 3 into y is square root of 3 into y minus square root of 3 into 4 is 4 square root of 3, and this is 1 into x is x minus 1 into 4 square root of 3 is 4 square root of 3. So we can write square root of 3 equals to x minus 4 square root of 3, and if we send this to the other side, it would be plus 4 square root of 3. So this 2 will cancel. Therefore square root of 3y equals to x. This is the equation of the normal.